Well, hello everyone. I am here with Chemistry Cat. Do you have mole problems? If so, call Avogadro 602-1023. So by now you should have watched your videos about the mole and Avogadro's number and what that really means. So Avogadro's number is a way that we do measurements within chemistry. And the mole is our SI base unit used to measure the amount of substance. And in 1 mole, whether it's atoms or particles or molecules, there are 6.02 times 10 to the 23rd atoms or particles or molecules, whatever it is that we're dealing with, in that 1 mole. Well, how much is a mole? Well, if we were to use our periodic table, which you're going to need from here on out to the end of the year, and a calculator, we can figure out how much of a substance we would need to weigh out, say on a balance or a scale, to get exactly a mole of a substance, which would contain 6.02 times 10 to the 23rd molecules, say, for instance. So molar mass is what we are going to be calculating today. And if we were to look, say, at this little bundle of iron right here, and say this little bundle has exactly 1 mole of iron in it, well, that means that it has 6.02 times 10 to the 23rd atoms of iron in this little package, this bundle. Well, how much would that weigh? This is where you need your periodic table. And if we look up the atomic mass of iron, it is 55.847. And since we're talking about molar mass, mass is always in grams. And if we're talking molar, then that means it's per 1 mole. So our unit is going to be gram per mole. Now, with the calculations we're going to be doing, we would like to round to 1 place past the decimal with all of our atomic masses. And so 55.8, does it stay at 55.8 or does it change to 55.9? Well, if you remember your rounding rules, you have to look at the number that follows where you want to stop with your rounding. So the 4, does that change the 8? No, it does not. 0, 1, 2, 3, 4 will not change the number in front. If this were a 5, a 6, a 7, an 8, or a 9, then that would make this a round to a 9, and it would be 55.9. So we're just going to go with 55.8 grams, which is equivalent to a mole, which is equivalent to 6.02 times 10 to the 23rd atoms of iron. So we'd weigh out 55.8 grams of iron, and we would have a mole. So we're going to be doing some calculations later in the week where we're converting between numbers of atoms, mass, and numbers of moles. So you're going to need a scientific calculator that can do powers of 10. Today, we just need a calculator where we can multiply and add. So if you see these terms, molar mass, formula mass, which is for ionic compounds, and molecular mass, which would be for molecules, which are covalently bonded together, we do the exact same kind of math. Essentially, we're finding the same thing. It's just different terms depending on the type of a substance that you have. So if you see molar mass, formula mass, or molecular mass, it's just the same type of math that we're going to be doing. So in our first example here, I have a grid set up. And now you do not need to draw the grid ever again. It's just to kind of keep our first example kind of straight so that we know what we're talking about. So we want to find the molecular mass of glucose, and the formula for glucose is C6H12O6. So the first thing we're going to do is write the element that is present in the formula. We have carbon, hydrogen, and oxygen. So C for carbon, the H for hydrogen, and the O for oxygen. It's very important that you work out your problems, your examples, your homework problems, etc., exactly like what we're showing here on these notes. And I hope that you're copying everything down as we are going through them. If we take a look at our formula again, we find that there are 6 atoms of carbon. So next to the carbon, we're going to put a 6. There are 12 hydrogens. Put a 12 next to the H. And there are 6 oxygens. Put the 6 next to the oxygen. Now we are going to multiply by the atomic mass of each of these elements. Where do you find the atomic mass? On your periodic table. So if we go to carbon, carbon on my periodic table has an atomic mass of 12.011. And we want to round to one place past the decimal. So we're going to go with 12.0. And it's important that you put the 0.0 down. Later on, it's going to matter a tremendous amount that we are rounding properly to one place past the decimal when we're doing our atomic masses, because your calculations will turn out correctly. Trust me on this. So hydrogen, if we look up the atomic mass of hydrogen, is 1.0079. So one place past the decimal is where we want to round to, and it comes out to be 1.0. Now oxygen. Oxygen is, I'm going to write that up here, 15.999. And we want to round to one place past the decimal. Well, this 9 makes this 9 round. And our rounding is going to take us to 16.0. Okay, so this 9 right here has the effect on this, which has the effect here. So 16.0 is what we want for oxygen. So get out your calculator. Time to do some math. So 6 times 12 is 72. And since we're multiplying 6 times 12.0, it's important that we put 72.0. 12.1.0 is 12.0. And 6 times 16.0 is 96.0. Now we're going to take the numbers here that we have just calculated and add them up to get a total. So 72.0 plus 12.0 plus 96.0 adds up to 180.0. And the units, gram per mole. So this is the final answer that we are after. This is our molecular mass of glucose. If we were to take a balance and pour onto that balance 180.0 grams of glucose, we would have exactly 1 mole of glucose. How many molecules would be in that sample of 180 grams? 6.02 times 10 to the 23rd molecules, which is a tremendously large number. Okay, let us move on to our next example. Again, you do not have to draw the grid, but we do have to show the substance that is present, all the elements in ammonium sulfide. Now notice we're asked to find the formula mass. That must indicate that this is an ionic compound. So nitrogen, hydrogen, and sulfur are in our formula. How many nitrogens do we have? There are 2. How many hydrogens? There are 8. And how many sulfurs? Just 1. Now we're going to multiply. What is the next number that goes next to each of these? The atomic mass. So get your periodic table. Nitrogen is 14.007, so that rounds to 14.0. Hydrogen, 1.0079, rounds to 1.0. And sulfur, and I'm going to write that 32.066 up here next to the sulfur. And again, we want to round to one place past the decimal. The 6 makes that 0 round to a 1. So 32.1. If you were tempted simply to write 32.0 down, in the long run, this is going to greatly affect our calculations when we get into some heavier math. So it's super important that you understand that we do have to round properly to one place past the decimal now and get into that good habit so that it will make our lives easier down the road. Okay, 2 times 14.0 is 28.0. 8 times 1.0 is 8.0. And 1 times 32.1 is 32.1. Yes, you have to show your math work all the time, every step. Don't cut corners. Okay. So this comes out to be 68.1, and we need units, gram per mole. And this is what we are after. Okay, so that's the formula mass of ammonium sulfide. Okay, so go ahead and pause the video and work out the next problem, and then when you're done working it out, start the video again so that you can see if you have gotten the right answer.